All right, so I think we might as well just get started. Um, all right, so today me and a few of my collaborators are going to be presenting some of the work that we've been doing at Vanderbilt in trying to use block-based programming, or a block-based programming environment, to help introduce text analysis to humanists. So this is work done with myself, or by my, this work has been done like on behalf of myself, Corey, Sarah, Burriss, Mark Schoenfield, and Clifford Anderson. And I think we're going to now have Mark take a moment here to explain some of his background and his questions of interest.
Hi, everyone. Yeah, I'm going to provide a brief background narration to kind of explain what research project initially brought us all together. You'll see as the discussion goes on that while these research questions still are active, new ones and pedagogical ones have also arose. So I have been working on a project about the culture of litigation that arises around 1800, where innovations like cross-examination and the rise of celebrity lawyers have changed how people experience not only the courtroom, but other spaces of adjudication. So in novels, household scenes take on a veneer of evidentiary proceedings, conversations between employer and employee start to echo the genre of cross-examination. Next slide. So in thinking about support for my contention, I was working extensively with British periodicals, the British Periodical Database. And as the screenshot suggests, it has some basic search functions and offers a lot of material. You can see here there are about 50,000 references to juries. And just clicking around, I came across a lot of interesting articles. But I wanted to dig deeper to treat these periodicals not only as historical references, but as cultural markers and literary productions. Our library, led by Cliff Anderson, both secured the XML files for the articles and began working with me on how various text mining operations might be useful. I'll just say for me, it was not the simple black box I had imagined and hoped for. Next slide. So this team emerged guided by an intersection of computer analysis and literary critical questions. Some are methodological and broad, such as the ones in larger type here. Could a systematic computer-assisted analysis of the 4 million articles in British periodicals supplement a close reading analysis of a subsection? And could it improve the selection of that subsection? So help me decide which of those 50,000 articles referencing juries I should look at. And could it raise new questions? Those in the smaller print below are samples of issues I believe data analysis can help answer. You'll see several are about how legal practices become generalized. So there's a reasonable hope that word usages and affinities will reveal underlying cultural aspects. So on that, I will pass the baton for the story to be continued.
Okay, yeah, I think it's up to me now. And so I just want to talk a little bit about the institutional context here. So as Mark mentioned, the library's been involved, and obviously we do a lot of information science in the library, but we continue to think more about like just how you search the library like item by item, but how you also search it as data. It's a big theme in librarianship now. And then there's these other intersecting groups that really kind of brought together the computer science education aspect of it. We have a group called the Computational Thinking and Learning Initiative, which is an internally funded group at Vanderbilt that brings together people from the School of Engineering, Arts and Science, the Peabody School of Education, some administrators like me, to think about how to scale computational thinking across the curriculum. We also have a Center for Digital Humanities that, for those of you in computer science education, I don't know how often you intersect with Center for Digital Digital Humanities in your disciplines, but we're trying to forge like closer relationships between people doing digital humanities work and computer science education, because it seems like they're really, really natural allies, but there hasn't been a lot of bridging work done to this point. So that's one of the things that we're focusing on. And we also have grants that bring together people at other institutions like Berea College and other places that have like-minded interests in text mining. So there are a lot of legs to this project. And one of the things that we've had a challenge to do is just to keep focused so that we can meet those goals that Mark articulated. All right, thanks.
So now bringing this all together, and we've in the context of block-based programming environments, one of our questions was basically, could we use block-based programming, in this case using NetsBox, to aid both in these research questions and the students' access to the in these text analytical concepts. So it would be great if we could give people tools that were that really lowered. This is really, I guess, an extreme case of really wanting to lower the threshold. So to make make these concepts more accessible, while also raising the ceiling enough to where it can actually answer some really questions that are really legitimate within the domain itself. So before we get in too much further, if you, I wanted to at least mention a little bit about what NetsBox is, and then discuss some of the approaches that we've tried to make some of these text analysis concepts, especially these kind of quantitative techniques, more accessible and understandable to students. So NetsBox itself is an extension of Snap, which provides a number of new features, most notably like some networking capabilities, but there's also a handful of other things like undo and collaborative editing, shared projects, sharing libraries, all these fun things. Now, the one of these new features that's of most, like most noteworthy for our usage, or for this case, is this concept of remote procedure calls. So essentially, this enables users to, within NetsBox, just have a block that essentially behaves a lot like a custom block, but the implementation is running elsewhere. So in other words, you run the block within NetsBox, and then it runs code on the NetsBox server or some other machine, and then can give you the results. So with that very brief explanation of NetsBox, I wanted to take the rest of the time to try to dig into some of the concrete examples and some of our motivation for them and things like that. So basically, we're using NetsBox again to look at a couple questions. Like some of interest to us are like this first kind of these three bulleted points here. Like, can we enable the students to interactively probe machine learning models to learn about the model's strengths and weaknesses? Oftentimes, artificial intelligence and machine learning can be kind of anthropomorphized and sensationalized in the media. So going into this, especially when people don't have a background in things like AI or like statistics or things like that, it can be really easy for them to view it as kind of an infallible black box. So one of the things that we wanted to kind of reinforce here was that, like, what if, like, can we actually give people this very interactive, much like this like Snap and Snap extension environments themselves, where they can kind of probe these models and start to understand, well, they're not just perfect, but further than that, can we start to hypothesize the causes of their errors and things like that? Even in a really general sense, or like broad strokes, not really being super detailed. So the first link that I had there. Oh, and of course, if anyone has any questions, feel free to enter them in the chat, and we've got some people monitoring that. So this was a really simple example that we started with. Now, the code that we see on the left is all of the code that's required for the project. And really what this project does is when I press this green flag, it will, I can basically write. It's like a typewriter, except it'll color code. It'll color code whatever I write based on the sentiment that it thinks it is. So if we read the text I've already written, it says, feel free to write about your day. And that's blue because it thinks that that's a positive thing to say. And I wrote, I first went to work, and that's black because it thinks it's neutral. And then it says, then I got a flat tire and was really angry, which is red. But I survived, I guess, which is neutral, or which I thought is neutral anyway. And then blue, which is, and then the next one is blue because it thinks that for lunch there was a birthday party, so I had cake with an exclamation point, is positive. So the nice thing about this example is that, let's see, so like, I love learning about text analysis. so you can enter some of these things like you are smart, you are not smart. And we can see what kind of things the model has learned. So the interesting thing I think about this exercise was that given our audience, again, the code to run it is shown here on the left. Essentially, it's a, when the green flag is clicked, it will continue this loop forever, where it just asks nothing. So it just pulls up this little dialog box for me to enter some text into. And then it saves the response as a message, and then just uses this RPC, get sentiment, using the parallel dots API. And we can always learn a little bit more about that if we just select parallel dots here, the language. And then we look at the help, it'll tell you what it is and where it is. And so we can actually look at, so we can see what powers this. We're not trying to have a black box on the NetsBox side, because really a lot of these questions, we want to try to expose a little bit more of this, not have it seem like this is simply magic. But anyway, it calls this get sentiment. It calls this get sentiment RPC, and then it just grabs the strongest sentiment, and if the strongest sentiment is positive, it changes the color to blue, otherwise red, or if it's negative, red, otherwise black if it's neutral, and then it just prints it. So this was a pretty, the thing that I liked about this project was that the amount of code required to make it was relatively simple, but so it could still serve as a nice introduction to programming and some of these computational thinking concepts themselves. But it also created a project that in itself was interactive and gave you access to some of these domain concepts. In other words, can we start probing this and wondering let's see, there are those Shakespearean insults. All right. So, so I got that. So either way, we can start grabbing text that's further and further away from what the underlying model was trained on, and then it starts bringing up some of these questions about why are basically the relationship between the training data and what the model's learning. Because again, these things often are anthropomorphized, and that makes it seem like it would make the same types of mistakes that humans do. But really, there are complementary strengths that we would like to leverage in both places, and I think that's valuable to highlight. Are there any questions on this one before I jump to the next one? Again, this is a very simple one. We can also do it with a number of the other APIs that are available or it's very easy to change this to use something other than sentiment. I should probably log in. So I certainly could use this for not translation. So you can see if something's abusive text, so which will catch things like profanity and stuff as well. We didn't do that one in class, but you can imagine if they find any weaknesses in the model, that could be goofy, or sarcasm, probability, or emotion, or things like that. But the reason why I pointed out this kind of transparency of being able to see the model, what's actually being used, is that we had some students who found that when they grabbed text, I believe one of the students grabbed text, I think, from the British periodicals itself, and saw that it seemed to disagree with what he would have labeled it, or what the label that he would have given it. So then, but the nice thing is that if you start looking through the API itself, you'll find that some of these things are trained on Yelp reviews. So it certainly isn't familiar with the terminology that was used in the 1800s. But anyway, but I think bringing up even those types of differences, I think are valuable questions. And let's see. And so I have some more slides just as another note on this. I can post these in the chat. I have extra slides at the end of this that talk about this in a little bit more detail. So talking about exactly what do we mean when we say probe existing models, why do we care about it, what question do we want them to have, what's the approach that we took, what the student questions might be, can I fool the model, what if I use historic text or really long sentences or unnatural punctuation, or does it care if I use all caps? And why do I think that these techniques do or don't fool the model? And what's the impact? Bringing this all back to what's the impact of the training data on the resultant model? So why do I think the model has these blind spots or doesn't have these blind spots? And is this a error with the training itself or the data? Just to try to kind of dig out some of those questions. Another example that we have is actually digging more into word embeddings, which are a little bit more of an advanced topic. But I think are topics that are still certainly of interest. Do of the people on the call, well, actually, I guess I can just explain them to start. So word embeddings are really just a numerical representation for words that are supposed to capture some of the meaning of the words. In one of the like initial like papers that that really made this popular, they were able to show that they trained this neural network on a bunch of text that they got from the internet, and it was able to and use that to generate these numerical representations for words based just off the text that it read. And they were able to show that you could reason that it basically learned some reasoning by analogy, such as taking the vector or the numerical representation for king, and they subtracted the queen vector. They were able, they took king and they subtracted, man and added woman, and that gave them the queen vector. So in other words, that kind of suggested that that these representations captured some of the meaning that we might care about if we want to try to reason about what's in the data. Now, people have taken have used these word embeddings for a lot of kind of like interesting tasks, especially in like bias and fairness, for example, where people have looked at these kind of like setting up these sort of similar analogies. And they've done it with word embeddings themselves and with like automatic machine or like machine translation, which is another case where it's kind of interesting. But like, so for example, one of the cases in machine translation is in Turkish, the word that they have for he and she is gender neutral, or sorry, yeah, he and she is gender neutral. So they have a gender neutral pronoun. So they would say that this gender neutral person is a doctor, and they would translate it to English where it has to choose between he and she. And when it says that the person is a doctor, it says he. If they say the person is, I can't remember what the other one was. Maybe secretary, it was she. I can't remember, but either way, they use these unsupervised like approaches to try to have a quantitative approach to being able to understand biases in the data, as well as a number of other things. But one of the concepts then, so this is an approach that seems like it would be pretty promising in the case of the British periodicals, because it didn't need anything except the documents themselves. For some of these other tasks, you actually need to have people go through and hand label them as true and false, or positive and negative, or things to that effect. Now, certainly if we had the human labels on all of the British periodicals, we probably wouldn't need the machine learned model. So it's kind of a funny problem that way. But so we have a few different projects that are in this space, some that are just for introducing word embeddings themselves. So we exposed to, so one of the things that we wanted to do was try to give students just a little environment where they could start playing around with what sorts of like actual embeddings, look up already trained embeddings, so don't worry about training or things like that, but just, can I get access to some numerical representations for things like king, queen, man, woman, house, and so on and so forth, and can I explore these word embeddings? And this is similar to some of the stuff that Ken Kahn has done. If you've seen it, if you are familiar with some of his work with the machine learning in SNAP, but you'll see in a moment it does get a bit different, because we, after this, try to step into students training their own, which has some additional complexities. But so one of the things that we did was we added this text analysis service, which gave us essentially custom blocks around getting pre-trained word embeddings or word vectors. So like I can do something like, get the word vector for cat. And this gives us a vector or a list of numbers that, in this case, is 300 numbers long. And it's supposed to be the representation that this model learned with, for cat. Now, what we ended up doing with this specific project was, again, still a little bit more students exploring it and things to that effect, but we were able to at least discuss some of the topics around like cosine similarity and try to start tiptoeing into some of these kind of relevant concepts, as well as just show that if we can do things like compute all the similarities to like the cat vector. And if we look at a ranking of all of just of the 20, so basically what this select students do is basically select or create some subset of words that they cared about, get the word vectors, and then explore those word vectors. So can I look at the similarity between them and see if it actually gives me a meaningful ranking of similarity and things to that effect? So, so like this one is an example where we computed all the similarities, and this one is specifically the ranking of these 20 words in terms of their similarity to cat. The interesting thing here is that like dog is pretty close, as we can see. Then we have mouse and caterpillar, but then we start getting into house, woman, man, tree, and things like that. Was that a question? I was hoping so. I always enjoy when these are interactive, so I can see where people are at and what people think.
I'll have a question for you then.
That sounds great.
This sounds really interesting. I missed the first part of your talk. Is after we leave here, how can we learn more about this? Is there a paper, and do you have any? Are these activities public yet, or?
Sure. So so I have a link. Let's see.
I do see the link to the slides, I think.
I have a better link, I think. One second. That one's like not a bad link, but so we have a few things. We have, oh, I didn't post the link here. So, so we have a link that's discussing how we are presenting. It's a Medium post. We have a Medium post where we've talked about this approach of just trying to kind of combine computational thinking into the humanities, specifically focusing on text analysis. Here I'll post it or update the proposal. So I'll post a link to the proposal for this talk, and then
great.
And then I can share some extra links in there so you can follow up and things like that. Awesome. Yeah. So basically this first project, or this second project really, the first project was like, can we start thinking quantitatively about text? Can we start, thank you, Cliff. And can we start thinking quantitatively about text? Can we start thinking about how these models are not necessarily these like anthropomorphized, infallible things, but these things that we can kind of probe and find mistakes in because their result is directly dependent on what they were trained on. So like in the example before, students were able to enter, text and from all sorts of different areas into this model that I believe was trained on Yelp data. And certainly they can find text that doesn't really match what they might see in Yelp. But then this brings up some of these questions and about really about the effect of training data and where can you have blind spots in your training data, which has come up in all sorts of topics ranging from ethics and fairness, and as well as just trying to perform or achieve a higher benchmark. Now so the second project then is focused more about like word embedding specifically are a topic or a technique that seemed promising in the context of British periodicals. Now, British periodicals, again, is this large data set that's of interest to, the group, and there are research questions that would be great to pursue in that area. Now, so now it's kind of tiptoeing into a specific approach, which is a little bit more advanced, but it's one that should be able to be applicable to the research questions of interest. Then this final project that I'm showing, and again, this is all still a work in progress. So we're still kind of evolving and growing, and and continuing on things in this route. But the final project that I'm going to show here is actually taking it to the next step and saying like, well, can we actually train our own word embeddings? So now that we played with word embeddings, could we actually generate some of our own? So this is I have a disclaimer at the top that it's still pretty like exploratory and things like that, but we have used it with the students so far or already. But so basically, this is an example where we took the Middlemarch book, which is a Victorian text, and it's you know, quite long. And then we first go through some of this data cleaning. So we have some blocks here that just, you know, convert all of Middlemarch to lowercase, split it by lines, remove the white space. Then we remove the empty lines, get rid of copyright text, get rid of chapter labels. So basically go through this kind of data pre-processing and data cleaning stage. So we can run this. And then we'll see that we go from, let's see. So we'll see, it'll take a moment because we're doing most of this just in blocks, or actually all of this just in blocks. There might be a network call in one of these, but we can see this, that we start with this text that's a little bit hard to see just because it's, oh, well, here we go. So because it's just a bunch of text itself, and then it splits it into, you know, sentences, and these are sentences that have some stemming, you know, so in other words, they remove the any like suffixes on the words just to try to make it basically so that you see the same word more often, so you don't think that things like quick and quickly are completely different words. So it does some data like pre-processing and things like that. Any of these steps, of course, you can just kind of inspect and tweak. And then we introduce a new service. Again, basically just another like, again, custom block that's running somewhere else, like remotely on a server. And this service is called datasets. And now the dataset service is basically, it just lets you build datasets or just send data or text or lists really to be saved on the server that we can then train a model on. The problem is that sometimes you need really large amounts of data, and it can be hard to load all that in the browser. So it's, especially if people are interested in moving to routes like Spark, where they're doing distributed data, or they're working with distributed data, this is kind of a stepping stone in that direction. So we're specifically sending all of our data to the server to store it, and then we could do things like fetch a bunch of it and put it there, and then just do all of our training on that machine. So I can do something here like create a variable. So after I run the scripts that pre-process the data, I create a variable called dataset, which I just save the name of the dataset that I'm using. So Middlemarch for, you know, my username. And then I create that dataset, and then I upload all of the sentences to the dataset. And once I've done that, now we can actually start looking at training a model. So we have this Word2Vec service, which is a new one that's under, again, text analysis, that lets us train a Word2Vec model. So I want to train our own word embeddings. And now I pass dataset, which in this case is, again, just a name of my dataset. And the Word2Vec model, or the Word2Vec service, has access to the dataset, so it'll look up that dataset, train a model that it's going to call Middlemarch model. And there are some optional arguments here that you can set. We're not going to worry about those for now. The optional arguments would be related to like the how big you want the vectors to be and things to that effect. Anyway, I basically about have to sum up here. So once they've trained it, they can do things like look at the most similar words. The really cool thing in this direction is that then you start running into like really practical considerations that I think are still intuitive enough for students to be able to understand. Like when we first started looking at this, we noticed, as shown in this, that I tried to show with this plot here, this is a plot of the similarity to the word duty of all of the words. And we can see that they seem like they're almost all similar, which is kind of weird. So we start exploring topics like around how do we know that we can trust a model? Because this model, as a little bit of a spoiler alert, doesn't have enough data. So if you train it multiple times, you might get different values and they won't agree with each other. But there are these still, like, I think, natural concepts that students can be exposed to within an environment like this, where they can actually be doing still very complex things, but still capturing the important concepts, I think, within this domain. But anyway, with that, I'm a minute over, or just over, so I'm going to have to wrap up. But if people have any questions, feel free to reach out. Again, I'm going to post more like another link and maybe some contact information on the proposal page. So if you check out our page on the SnapCon website, you can certainly reach out and follow up, and we'd love to talk to you guys about it some more.
Awesome, thank you.
And I think we've got time because the next session is, I think, the one that I'm doing with Garthi Narasimham, and so we can hang around. I think we're at a break right now, but if anyone wants to ask questions during the break, we'd be glad to hang around and talk to you all.
Yeah, I'm wondering, for somebody who's used Snap, I'm not that familiar with InNet Blocks. Is it a pretty easy transition from Snap to NetsBox, or however you say it?
Yeah, no worries. Yeah, it's a pretty straightforward transition. I mean, if it's kind of wild, you know, with the 30-minute talk, I don't have a ton of time to go through all those details during that part of it, or so I kind of went over some of those parts pretty quickly. But the transition should be pretty straightforward or pretty simple. Basically, some of the most notable differences are that we have this network category, which lets you do things like the first four, which are related to like message passing. So you can send messages between computers. So you could make like multiplayer games and things. Not really relevant for this session, but it's just one of the differences in NetsBox. And then we have these network blocks for call and run. And again, these are just calling code that runs somewhere else. So it's like we can do this for example, one of the examples that we often start with, I don't know, let's just enter some value here, is like a task related to like mapping. So you can do things like use the Google Maps service to get access to a map. And this gives us a map of some region. Yeah. And we could do things like put that map on as a costume. So now we have that image. So there are so basically it exposes these call blocks. You could think of them as a very large library of custom blocks that again are implemented somewhere else. So they
so your language library is specific to NetsBox.
So yeah, so like things like this language category has services like parallel dots and translation. All of these blocks are specific to NetsBox. Okay. Now, there are some other features and things as well, but those are I think most prominent. So I could, and especially like I guess maybe the big thing to say is that if you're coming from Snap, you can basically write Snap programs in here with, like, we don't have the latest or the object-oriented support, but other than that, we have basically most of the other things. Again, we're going to be adding the hyperblocks. We have to catch up a little bit on that one, but.
Oh, so NetBlocks is that a Vandy project?
Yep. Yeah, it was created out of Vanderbilt, trying to bring distributed computing concepts to Snap. Because you have Scratch, you have Snap, which already improved on Scratch by adding a lot of these functional programming concepts and really powerful abstractions. So you can learn a lot more computer science principles in it. And then NetsBox basically tried to take that and say, we're living in such an interconnected world. It would be really great if students could actually experience that as a creator, rather than just a consumer of, like programs on their phone and stuff.
Yeah. That's cool. I'll have to check it out. I know somebody, Julie Johnson, I think, teaches at Vanderbilt.
Yep.
The name sounds familiar.
Yep. She's in computer science as a professor of the practice. She's a great, great leader.
Yeah, I wonder if she's seen this. She might be interested.
Absolutely. Yeah.
Because I think really I think the winds that are blowing is that classical CS, really people need to catch up and start teaching more machine learning and NLP or NLU. And I think this is a great bridge to help teachers, not only middle school, high school, but also college to embrace this new paradigm of learning from data.
Yeah, definitely.
So great work. It's very interesting.
Thank you.
Thank you so much. I think if there are no more questions, I will wrap up and say that we really appreciate all of you being here. And we plan to continue this work in the fall with some fresh students and some returning students to work on continuing to build these models and probe and test them to see how we can bring more students into learning about doing text analysis with NetsBox and these tools.
Can I ask one more question? Are you going to use BERT models?
Yes, it's a good question. So right now we had focused on, we had started and just been using Word2Vec just because it was a kind of like basically the one that started a lot of these, this real exploration to all these different methods of training word embeddings. I mean, I'm not opposed to it. Since I was focused mostly on the concepts at this point, and we hadn't yet hit the research level, I didn't see the need to yet, but I think once we start exploring, like applying these to the British periodicals, then I think it would probably be useful to explore some of the even more recent like approaches.
Yeah. One more thing I just want to say, as we're in an era of trying to reach more students of color, you know, maybe some different types of text might be more appealing, or, you know, if we include other text aside from British literature.
Yeah, yeah, definitely.
But thank you very much.
You're welcome.
Bye-bye.
See you later.
Bye.
Thank you.
Yes.